Hello, everyone. We're very pleased to welcome so many of you to this webinar today. My name is Stephanie Kidder. I'm the CMO at Cosmo Tech. Cosmo Tech provides holistic digital twin simulation software to solve the most complex industrial problems and lead enterprise decision-making. Today, we have a really great lineup of speakers, and we will be talking about the move from traditional to resilient supply chain planning. Gartner analyst Tim Payne recently published a report on this topic, and he says that the rise of resilient planning changes just about everything for supply chain planners. They need to become familiar with the differences this paradigm shift brings versus traditional planning, and this is what we will be discussing with our panel of experts today. But first off, let's start with just a few housekeeping items. So all participants are in listen-only mode. A Q&A will be held at the end, but you can submit your questions at any time in the questions box in your GoToWebinar interface. We apologize ahead of time if there are any technical or connection issues. We hope that that will not happen. It usually does not, but you never know. And anyway, the recording, if something were to happen, the recording of the webinar will be sent to all attendees tomorrow. So let's get started with a round of introductions by our panel. Serge, would you like to start?
Yeah, so Sergio Cosmin, I'm the CEO of DigitforHuman, and before that, I spent 25 years in the Renault-Nissan Alliance in marketing and sales position, supply chain position, and then strategy, and finally, as the last position, head of the subsidiary in charge of digital transformation, Renault Digital, and very happy to be with you.
Great. Dimitri?
Dimitri Obolensky, located in Paris. I'm part of Microsoft's global automotive teams where I have a strategy consulting position. Very happy to be here.
And Roma?
Hello everyone, I'm Romain Ropito. I'm a senior product manager at Cosmo Tech, responsible for digital supply chain twin solution. And I have 10 years experience in consulting firms in supply chain and operations.
Great, well, thanks everyone. I'm really excited for our discussion, but let's get started to start this off actually with a poll question. So I'm going to take the first question and launch it. So you should see the question on your screen. So the question is, what are your supply chain priorities in the next year? The choices that we have are supply chain resiliency, operational efficiency, reduce carbon footprint, improve service performance, or bringing new products to market. So I'll give you, a few seconds, maybe a minute to put your responses in there. Okay, we're about halfway there. Half of you have voted. Give you a few more seconds so that everyone can get their vote in. Okay, a few stragglers. Okay, great. Well, I'm going to close it there. We don't have quite everyone, but we'd like to get started. So let's close that, and we can see the results. Well, it looks like the topic is a good one. You came for the right reason. 69% of you say supply chain resiliency is going to be a priority for you this year. Operational efficiency, reducing the carbon footprint, and then improving service performance and bringing new products to market are towards the end. So let's go back to the presentation. So let's dive into the main topic. What is the difference between traditional and resilient planning? Let's start with the definition. The ability of this is the definition actually that Gartner gives for what a resilient organization is, resiliency in an organization. The ability of an organization to resist, absorb, recover, and adapt to business disruption, in an ever-changing and increasingly complex environment, to enable it to deliver its objectives, rebound, and prosper. In the current context today, of course, resiliency is more important than ever. Your responses to the poll have shown us that. On the right-hand side, you see a table from the report from Tim Payne that I mentioned earlier that compares 10 differences in key attributes of the two approaches. I'm not going to read all of them now. You may have had time to read some of them in the time I've been speaking, but we will be covering a number of these today with our panelists. So first thing I will do now is hand the floor over to Dimitri. Oops, sorry, wrong direction.
So I would like to start to shape a little bit the drivers of this complexity and uncover why it is complicated for a manufacturing player. And here the example is with an automotive OEM. Why is it complex to plan in the supply chain? So typically, automotive OEMs work with a very complex network of suppliers with lots of different layers. Of course, they know very well the first layer. They're tier 1 suppliers. They have direct relationships with them. Even at this stage, they have already tens of thousands suppliers. But of course, each of these suppliers has its own network of suppliers. And then starts the unknown part of what happens in the supply chain. There they have hundreds of thousands of sub-suppliers. And the first question they need to be able to answer is, who are they? What happens to them? Of course, every time that something happens in one of the tiers, at the end of the day, it's the OEM capacity to produce that can be impacted. So keeping that in mind is already a first important thing. If we then move to the next slide, we can see what are the risks that are created by an inability to supply at the lowest tiers. So first, you have an operational risk. The impact is just the inability to produce vehicles. Some root causes for that can be that the supplier or the supplier is unable to provide parts because of an interrupted logistics road. Let's take a situation where you have, I don't know, a flood or a war or a natural catastrophe. The road is cut, and some days, weeks, or months later, suppliers get out of stock, and eventually the OEM is not able to produce anymore. You can have long-term plant outages. You can have M&A movements, a sub-supplier being acquired potentially by a competitor of the OEM, and then it's the OEM itself that can't produce anymore. A second type of risk is more reputational. And today with some regulations, for example, in France with the Loi Sapin, eventually it's the OEM who is responsible for the corporate and social responsibility impact. So if a sub-supplier supplies from a country that has negative coverage, or if a sub-supplier is facing some ethics scandals like sweatshops or children work, then it's the reputation of the OEM who is impacted at the end of the day. And with social networks, it gets big coverage and everybody knows about it, and you have some boycott campaigns against the OEM. And the last thing is about the profit risk. So the OEM would still be able to produce vehicles, but with a very negative impact on profit because one sub-supplier owns a monopoly in the chain and imposes the prices or pulls the prices up. Today, because they don't know who their tier N suppliers are, the OEM get aware of the situation pretty late, and thus they cannot proactively manage risk. If we move to the next slide, it's to make this a little bit more visual and to show with a very simple example how this complexity comes in. The traditional approach to manage those risks is to keep safety stocks as all echelons of the supply chain. So here, very simple example, we start with a mining facility in Australia that produces some minerals that are used in a plant in China to produce batteries. And those batteries are then shipped by boat to not only a plant in Turkey where some cars are produced, some electric cars are produced, but as well directly to the OEM in France to have replacement parts for those electric vehicles. You can take an event in any part of the chain, and the whole chain is broken, especially because, of course, OEMs tend to keep low stocks. They typically have 2 days of stock in the plant. but a major problem can impact that for a much longer period. So everybody is keeping safety stocks. So the mining warehouse in Australia keeps safety stocks for the mineral. Then the Chinese plant for batteries keeps not only stocks for the mineral, but as well for batteries to be still able to ship if they can't produce anymore. The plant in Turkey keeps in its warehouse some safety stocks for batteries and for cars for the same reason. And eventually the OEM keeps as well safety stocks for cars and for batteries to replace. The impact of all this is, of course, they all immobilized huge amount of cash. And today they don't have cash. If you replicate that at the order of magnitude of an OEM supply chain, remember, tens of thousands of suppliers, then you've got tens of thousands of those routes, you've got 10,000 of those safety stocks for all parts, for cars, for all models of cars. It becomes a very important management problem and a massively complex endeavor to manage that in the proper way. So for all this, they need data, and well, the data, good news, they have that data, but often in not a format they can concretely use. All this is not science fiction. As we'll see in the next slide, it happens actually. So I will show you two examples which shows that safety stocks based approach is not even effective. Take an example, very recent one with COVID-19. I have a customer who is an OEM who has a distribution center in Lombardia to service cars across the entire country. When the COVID-19 crisis started, some of the villages where the workers were living were in those red zones. And eventually the DC workers were not able to come to work. And eventually the DC got blocked. And eventually the OEM couldn't serve car across the entire country. A second example is pretty well known now in the automotive industry, is related to a painting plant that was in the Fukushima region. When the tsunami came, it destroyed the painting plant. All the safety stocks got depleted in months, and eventually tier ones were not able to deliver after 6 months. Reactive analysis of the OEM showed that this sub-supplier had a monopoly, and then started a rat race between all the OEMs to find an alternative. Of course, the alternative was expensive, very expensive, impacted profit. And you can see that many times, plants which are on fire, plants which are broken by a hazardous event. So it happens every day. So they need to find some new solutions, and now Serge will draft some of them.
Thank you, Dimitri. I will try to illustrate actually 3 of the conditions that Gartner is proposing for a move from traditional to resilient planning. The first one, if you can move forward, is alignment of planning processes, generally in the automotive industry, but not only. You have 3 layers or 3 levels of planning. You have midterm, 3 to 5 years. You have yearly and budget, and you have the ops, basically monthly and weekly. And most of the time, and I will illustrate that, those processes and the systems that are behind them are not integrated, not aligned, leading to discrepancies. The second condition to move from traditional planning versus resilient planning is to move from periodic to continuous planning at all levels, not only at the ops level, but also at least at the yearly budget level. And finally, the third condition I will try to illustrate is the use of buffers. Buffers normally should amortize the movements and in the demand. And I'll show, this is a very well-known so-called bullwhip effect, that actually the way the buffers are used in the automotive industry are amplifying movements rather than amortizing them. So giving some very concrete example on the first condition, if you can move. Two examples. The first one is the shift from diesel to gasoline on the European market. It was a lot faster than what was expected by the automotive industry. basically because there were some feedback loops on the move from diesel to gasoline. It was not only a pricing effect, it was also a residual value of the vehicle effect. It was also a reputation effect. I mean, the result was that the move was really extremely fast from one month to the other. If you can align your ops, where this movement was seen to the yearly and especially to the midterm plan fast enough, then you have you can manage the discrepancy between what you were expecting and what's really happening on the market. Generally, that was not the case, and there was a delay in terms of capacity planning for engines and supplier planning for parts of the engines. The other simpler example is, typically if you install a feature or an option with an expected ratio of mounts in the cars, typically a GPS, that was some time ago. If you expect 10% option rate, and if the actual sales are 50%, then not only obviously you have a short-term capacity issue and delivery issue, but you have also to feed it back as soon as possible and as fast as possible to your supplier capacity planning in the midterm, to what you do in terms of supplier's choice for future vehicles. And this, once again, requires alignment of planning processes between short, mid, and long term. Second set of illustration. Why should you plan continuously if you could, which is not always, I would say, the case in the automotive industry. Obviously, catastrophic events do not comply with planning schedule. COVID is, I would tend to say, a very severe illustration of it. But it's not, only large catastrophic events that are involved. On the right-hand side, you can see a curve. You cannot guess what it is. It's actually the evolution of the Turkish lira versus a basket of currencies. Turkey is both a significant market, but also a production market. The way the currency is moving has a strong impact on the profitability of the vehicles that you produce in Turkey, but also of the profitability of the vehicles that you export to Turkey. And if you cannot take into account very significant movements on the currency very fast, then you end up either with unsaleable inventories or with a very strong impact on the profit of the company. The other illustration that I can give is what I call chicken and egg sales versus production planning. And this is more, I would say, on a longer term process. Generally, the way it's being done in the automotive industry, you start with a sales scenario. If you want to build your midterm planning, you do it, for example, in March or April. Then you build a manufacturing plan, including supplier capacity, around the summer, and you have costs linked with this manufacturing plan. But in the meantime, if you can move, please. Yeah. In the meantime, the sales scenario can move, because between March, when you started with the sales hypothesis, and when you end up with cost in September, for example, the market can have changed. And the sales scenario that you have in September is not anymore consistent with the manufacturing plan that you have, and not consistent with the cost. Then you have an inconsistency between revenue and cost that is significant. The only way to manage this discrepancy is to be able to move more continuously, both on the sales scenario and the manufacturing plan as well, which requires integration of the planning tools. Last illustration on buffers. So the bullwhip effect is basically, if you have a small variation in consumer demand, then you have, in terms of forecast, a more important variation expected by the retailers. The retailers will then request an additional number of vehicles so that they would be able to sell to cover the predicted sales that they see. The wholesaler that is consolidating the request from retailers will add a security margin. Then the manufacturer will do the same, and the supplier, seeing those variations, will do the same. What is wrong here is that actually the buffers that are standard buffers, that are based on a given ratio versus the future sales. Generally, it's a few days up to, as far as car industry is up to 15 days to a month of inventory. I mean, if you use them in a mechanical way, I would say, they will amplify the bullwhip effect and the nervousness of the planning process. And on top of that, all the actors, and especially the retailers and the wholesalers, knowing that there is an amplification, will add, if I can say so, their own precautionary movement, which means that they will probably overestimate the uptick in sales, so that they're sure that they will receive enough production to cover their own sales. So I mean, the buffers, rather than amortize the movement, will amplify the movement, because they used in a standard way rather than really used, and allowing inventory to amortize the movement rather than amplifying them. So 3 illustrations on what you must change to go from traditional to a more resilient planning. And I'll give the word to Romain to explain what can be done.
Thank you, Serge. First of all, I'm sorry if you are crying behind me. That's my 6-month baby. Sorry for that. I will explain 3 other characteristics of resilient planning. First of all, the one you see in the screen is a crucial prerequisite for resilient planning. It's the ability to accurately model supply chain behavior. Today, traditional planning solutions are now using a single data model in order to ensure the alignment between demand and supply side. But it's not enough. This single data model are today static, if we talk about, for example, lead times, cycle time, and so on, and they do not accurately reflect what happens in the reality. A digital supply chain twin goes further. It includes the representation of entities, hierarchies, interaction, the dynamic between the different entities, and the thinnest and fine policies representation between the different entities. It also encapsulates the representation of variability and uncertainty, which is not the case of single static data model. And at last, a characteristic of a digital supply chain twin is the fact that it is connected to the physical supply chain. And for some of them, it's near real time, thanks to IoT mechanisms, for example. So a concrete example of the digital twin representation is, for example, if you are working on a supplier network optimization, you can represent as traditionally every supplier with a fixed, predetermined or forecasted production planning, and try to see if everything is well aligned and so on, and make your planning based on that. But if you have a true digital twin, then you are able to represent every supplier with its own cycle time, its own reject rate, for example, its own uncertainties on capacities, and you can represent it differently supplier per supplier. And that's the whole dynamic that you will run when you will simulate it. So you can imagine that it's not the same level of detail that you are describing first and then simulating. For example, you can, with a digital twin, represent the fact that a yield will decrease when you will increase the diversity to process for a machine, for example. And this, you do not know it in advance. You have to run a simulation to see what is the daily diversity to process at a certain time step, and then you can deduce what will be the yield. And it is not static data that you have predetermined or forecasted. It's just a representation of real life. Another example is the fact that a machine failure probability will also depend on the sequence of the product you will process on the machine. And it's one more example where you are not able to precisely determine it for the future. You just want to play a scenario to see what will be the sequence and to deduce the failure probability and then to impact one more time the capacity. All these mechanisms are integrated in a digital supply chain twin in order to be a real granular mirror of a reality. Then if we go to the next slide, another crucial characteristic of a resilient planning is the fact, still based on your digital twin, to include stochasticity inside your planning. Stochasticity means random. It describes any process where you include hazard, uncertainties, unexpected events. And as you know, the real world is volatile and uncertain today, and even more today than in the past, I think. A resilient planning takes full account of this stochastic behavior in order then to appropriate the different tactics that you want to play. And when we talk about supply chain, stochasticity is everywhere. You have random and unexpected events within demand. You have it also on capacity side and on everything linked to lead times. And to be representative, your digital twin must include all this kind of uncertainty on these different type of parameters. And you have to be able to represent this randomness, let's say, time step per time step, and with not a static behavior, but with something that you do not really control. So you have to be able to put as an entry, for example, a range of a variation for parameters, and then to play a probability and occurrence on every parameter. And it's key to be able not to represent one single uncertainty on only one parameter, but to be able to combine these uncertainties between each other. Because maybe your supply chain could be resilient to a change in demand, but are you sure that it will be resilient to this change in demand if on the same time you have an unexpected event on transport, for example, and on the same time you have one supplier that has a lack of capacity that was not planned? In that case, you have a combination of uncertainties, and maybe that your safety stock, traditional safety stock, are not enough. If you have resilience planning, you are able to include stochasticity in that and simulate this possible combination and play scenarios as we will see later. So if we come back to our example of supplier network optimization, if you are, for example, responsible for a sourcing strategy, your goal is, of course, to ensure a maximum service level, while at the same time minimizing the total landed cost. That's traditional objectives of a supply chain manager, let's say. If you do not integrate uncertainties on that, then you're dead. You do not know what will happen. You can try to forecast it, but if you only play one scenario with one possible value for a parameter, you are sure that you are next to what will be the future. So you need to combine to optimize your supplier network all these three uncertainties. And maybe that you should also add some other uncertainties, as explained by Serge. You could add uncertainties, or for example, on currencies, because it has a big impact on your strategy and on your final profit. And you can also add uncertainties on the custom costs, for example, because you do not know what could happen tomorrow. And it can dramatically drive you to change your strategy from a local to import strategy, for example. That's what is possible with stochastic-based planning. And then a third characteristic that is really key if you want to play and to really build a resilient planning is the scenario simulation. These days, pretty much every planning solution of every type can support some form of scenario planning. That's usual. But very often, it's a manual way of doing it. You just manually change one parameter and see the impact. And this is really limiting the capacity to test the supply chain resiliency against the real world infinite amount of possible features. That's why usually these scenarios are only reactive scenarios. Once you have an unexpected event, you would like to play an alternative scenario in order to find a solution to your problem. Under resilient planning, the vast majority of scenarios will be pre-event. Every pre-event scenario, for example, will correspond to a combination of uncertainties in any part of your supply chain, assuming, of course, that you have a stochastic-based planning. That is a prerequisite. Then the simulation of these pre-event scenarios cannot be run manually. Otherwise, you will spend your life to do it. You need to have automated advanced features to test it and to explore the different parameters. And for example, these features could be auto optimization, it could be risk impact assessment, sensitivity analysis, and all these features will include the fact that they will run parameters exploration, and behind that you have many scenarios, and when I say many, it's the range of 10,000 or even 100,000 of scenarios. So it's really not the same scale as traditional planning. Of course, to do it in a reasonable calculation time, there is a big prerequisite also, is the fact that you need to be able to run simulation on hyperscale cloud computing. Otherwise, you will not have enough calculation power to do it. And the benefit of this approach of running 10,000, 100,000 of scenarios is the fact that you will be able to be really proactive, because you will play a lot of scenarios, many scenarios, and you will be able to be prepared to any probable combination of risk. And thanks to that, you will have a library of scenarios ready to be used in the case you face an unexpected event. And once it's a scenario that you have prepared in advance, they will be optimized by nature, because you are not in a rush to do it. You have the time to optimize the things. So it's also a new business within supply chain. You are no more a fireman in supply chain. You are a person that anticipates the risk and anticipate proactively all the risk. And one more time, if we come back to our example of supplier network optimization, what could be very interesting when you have 10,000 of suppliers is to be able to, first of all, represent it, include stochasticity behavior inside that, and then to stress this upstream supply chain to be able to detect where could be the bottlenecks, where are the weakest resources, is it a supplier, is it a transport? And then once you have identified it, you can run some alternative scenario to try to mitigate this risk. And if you are not able to mitigate every risk, then you can at least have a prepared B plan in the case you face this risk. And another example on this kind of supplier network optimization could be that you want to position and size the right buffer at the right location and at the right size. If you do it without stochasticity, and by playing only 1, 2, or let's say even 10 scenarios, by trying to anticipate what could be the demand, use some average figures to position and to size your safety stock, it could be a first approach. But you are not sure that it will be robust enough to what can happen in the reality. If you are able then to include stochasticity and run 10,000 of scenarios, then you will really test your resiliency of the supply chain and make sure that you have right size and position all your safety stocks. And now I will let the hand back to Stephanie for conclusion.
Okay, great, thanks. So thanks, Roman. That was very interesting. Actually, all of the presentations were. I'm going to come back to our polls. Oops, all right. So our next poll question. Oh, it's showing, sorry. It's showing the results from the last one, which we already went over. So I'll hide that and now come back to our second one. So in this one, you can actually choose multiple responses. So what are your top obstacles to achieve resilient supply chain planning? We have data availability and quality, visibility across the supply chain network, lack the necessary people to work on projects, increased volatility and disruptions, and cost. You can choose multiple answers there. Oh, sorry, let me launch the poll. You should see it now with the questions I just read. Okay. Okay, it's in progress. I should be able to answer your, there we go. The answers are coming in. Okay, we've got about 39% voted. Maybe while they're voting, I can actually question. Maybe Serge, you've worked quite a long time in the automotive industry. Can you think of an example where resiliency really would have helped you or your company in the past?
Well, I've many examples. I mean, probably the one that is was most striking for me. I mean, was after the Lehman shock in 2000. I mean, starting 2007, but I mean, actually, the impact on the automotive market was in 2008. The market was extremely unstable, and the variation in terms of automotive market were huge from one country to the other, starting September 2008 and lasted at least 1.5 years. And we had to redo budgets and redo production planning a number of times. And at that time, I was working in Nissan. Most of the tools we had were well, Excel based in terms of scenarios. And that was really a nightmare in terms of trying to cope with the new variations and trying to cope with the large inventories that appeared in places. So obviously, I mean, both in terms of pre-event, because we knew it was coming in terms of shock, in terms of pre-event scenarios, in terms of being able to run multiple scenarios and integrating operations with more long-term planning would have been extremely useful.
Mm-hmm. Great. Thanks for that. Okay, I'm going to close the poll. There's 56%. And you should be able to see the responses. Can you see that? Okay, great. So yeah, data availability and quality. That's not surprising. I think that's a question that everyone hears a lot, that we don't have good data, the quality's not there, or it's not, we have it, but just can't quite get access to it, those kind of things. How big of a constraint is that? Do you hear it? I mean, Dimitri, for example, you work with a lot of companies, I'm sure, as they're coming over to the Azure platform. Is data availability and quality something that's a big constraint for them in for resilient planning? I think you might be on mute.
Actually,
sorry about that. You were on mute.
Okay, no problem. No, I was saying the bad news for everything we explained is that typically companies think they don't have the data. The good news is that they do have them actually, but they do have them in a non-very leverageable format. Typically, it's in paper. Companies ask for their suppliers to provide a view on their sub-suppliers' networks. And tier ones, for example, in automotive, provide them as a paper, as a picture, and it's then stored in some database of the procurement department that keep 300,000 of documents or 500,000 of documents that explain who the sub-suppliers are. Then what we can do as Microsoft is help these companies to retrieve that unstructured data and make it structured so it's leverageable for planning.
Mm-hmm. Yeah, which is important if they want to have really advanced and real-time, I guess, reactions and plans for this and for the resiliency.
Yep. If I may add something to what Dimitri said, which is extremely true, is that there is one more obstacle, which is most of the time those data are in silos. Some will be in purchasing or procurement, some will be in manufacturing, some will be in sales planning. And the key in resilient planning is to break those silos so that there is a common pool of data for the company to be able to do resilient planning.
Mm-hmm. That kind of addresses the second response on this poll here, with the visibility across the supply chain network being an issue for everyone.
And the data availability, because most actors don't think that the data are not available because they are just stuck in a silo that they don't see.
Mm-hmm. Romain, if I've understood, for simulation, for example, you don't always need to have all of the data to start getting started on running scenarios. Is that true?
Yeah, that's a very important point, of course. Here during this presentation, we didn't talk about machine learning, for example. It's because of the fact that a digital twin do not need a bunch of historical data to be able to run a first simulation and to have a first model working. And that's a good news, because if you have first level of data, of course, you can still improve the reliability and of that data and the quantity you need. But you can start describing the model, describing the supplier network with first reduced amount of data, describing how it is working today. You do not need to describe how it was working last year or 10 last years. It will not help you to understand how it will work today and tomorrow. So we just need to be able to describe the as-is situation, and with that you can start. And of course, then about that you could add some machine learning algorithm in order to improve step by step the reliability.
Right. Okay. Yeah. So that's it's a way for them to get started, a first step, and then move on to, well, they're actually collecting all that data from different files and putting it in the right structured format that they need.
Yeah, exactly.
Before we go on to the rest of the Q&A, I just want to say we have, based on the report from Gartner, which we will also be sending to you, it takes from this report checklists. So if you're really wondering how you can get started, we've built this resilient supply chain planning checklist to find out how ready are you and what you need to get in place to actually be able to build a really strong, powerful, resilient supply chain planning strategy. We will be sending to you a link to download this checklist in the next days coming. So in a couple of other questions that we have here, of course, be sure to answer your question or put your questions in. I see that there are some here. Hang on, quite a few. We can get this. Sorry, I'm trying to get down there. Excuse me. Okay. How do you calibrate your model to be sure that the model is reliable?
That's a good question. Of course, it's one of the first steps, and that's why we have to start with a reduce scope in order to make sure that we have modeled your supply chain or your perimeter at the right level of granularity, first of all, to be able to represent what happened in reality. And we check the output of a simulation with the real data on the field. And we say that the model is validated once we are able to represent the output quality as we can measure it directly on the field.
Okay. Another question here, doing digital twins for modeling and simulating supply chain networks is not new. What is really new in your solution? I think that's for you, Romain.
Yeah, maybe. If it's not true for you, that's very good news. I think it's new for the majority of people. Digital twin, as Gartner said, it's an emergent technology today related to supply chain planning. So it's not something that we usually encounter within our prospect or customers. Usually they are using ERP and APS solution in order to make supply chain planning, and they do not have this level of modeling and simulation inside these tools. So the really new thing in that approach is the granularity of the modeling, and then the capacity to simulate, to integrate stochasticity, and then advanced features like auto optimization, automated sensitivity analysis, and so on.
Okay. Is that something that you've seen also? Maybe I think that other tools have some limited simulation. Has that been your experience also too, Serge or Dimitri?
No, what I can say is that, I mean, what is not new in the automotive industry or in the industry in general is, I mean, I would say traditional digital twins, modelization of robots, or modelization of a press and so on, I mean, automated. And you can use it to simulate probable breakdowns. The difference in the approach that is proposed by Cosmo Tech is that it's really simulating the structure and the dynamic behavior of the structure rather than simulating a specific robot or a specific part of the manufacturing chain. So for me, this is the big difference, and I haven't seen that in the industry at this stage.
I would say as well, what is new in the approach is that it's cost effective. Typically, you can't find a manufacturer that would allocate big costs for risk management, because it's difficult to have a business case against risk management. It's full of probabilities, and so it would come at a quite late stage in the prioritization list. Now, with on-demand computing capacity in the cloud, you can do that effectively. It's the same than for artificial intelligence. The concepts are very old, but it's now leverageable and doable because you can access the data, and you can do that cost effectively.
Great. All right. I don't have any other questions from the viewers. I think that we're getting towards, we've got 40 minutes. If there's any other things you would like to add, maybe some last recommendations about resiliency and things that they should be looking at, or next steps that they should be doing. Probably covered it all. All right. Well, it was really, really great having you guys, everyone. It was very interesting discussion. Dimitri, Serge, Romain, thank you for that. If you weren't able to send your questions here, feel free to send us questions. We will be sending you a recording tomorrow and the supply chain checklist also, so that you can actually check out how you are performing or what your next step should be to becoming more resilient. At any rate, we are definitely here for any questions that you might have, or to set up a demo if you'd like to learn more how it works in detail. Great.
Thank you.
Stephanie.